As a way to guide the main features that we'll aspire to build in our own blockchain and cryptocurrency, we'll look at the original white paper of Bitcoin itself. So we'll take the main concepts of Bitcoin and incorporate those into our own implementation. So the Bitcoin PDF was a white paper published to Bitcoin's website on October 31st, 2008, that introduced the main features, ideas, and innovations behind the Bitcoin cryptocurrency. A white paper is an official report or document released by governments, as well as organizations or other companies that want to outline information and proposals on a certain issue. So back in 2008, the mysterious Satoshi Nakamoto published the Bitcoin white paper. He's mysterious because, to this day, we still don't know his or her identity, or even if Nakamoto is one individual or a group of individuals. Although there are some theories that float around the internet from time to time, which you can look up yourself. So that's pretty impressive, considering he or she or they is worth billions of dollars at this point due to their share in Bitcoin. So I highly recommend reading the white paper yourself, as it's very clear and will provide a solid background of how a cryptocurrency like Bitcoin itself works. It's 8 pages and divided into 12 sections, including an introduction and conclusion. So 10 of those sections outline main features. So in the upcoming slides, note that the diagrams and textual excerpts come from that Bitcoin white paper and those sections. So after the first intro section, we have a section on transactions. In this section, Nakamoto explains the need for individuals to sign their transactions with their unique signatures using private keys. So this is something we'll include with the transactions in our own cryptocurrency. Next, Nakamoto brings up the timestamp server, which is a necessary component for the blocks in order to order them properly in the blockchain. Each unique hash value of a new block in the chain incorporates a timestamp of the last block. That way, a chain is created based on the linked hashes of each block. Then we have the fourth section, labeled Proof of Work, which details how miners will add blocks by solving a computational puzzle that ensures blocks aren't added at too quick of a pace. So the paper itself provides details on how the proof of work algorithm is implemented. Notice the use of an SHA-256 algorithm, which we'll be using in our own implementation as well. The proof of work algorithm also ensures that the blockchain incorporates data from honest miners, since this makes it exponentially more difficult for an attacker to take over the blockchain network, since they would have to outdo the computational work that has been done by all the honest miners in the system so far, which at this Bitcoin is impossibly expensive. In our own blockchain, we'll use a similar proof of work algorithm with SHA-256 as Bitcoins, and we'll dive into the nitty-gritty details of proof of work, such as its nonce value with the 0 bits, and having those specific 0 bits as leading zeros to the hash value as we get to implementing the feature soon. Next, Nakamoto brings up the Bitcoin network. As such, we'll support our own network for multiple miners and users of our own blockchain and cryptocurrency. Then there's a section on the incentive, which is a reward that miners receive once they solve the proof of work algorithm and gain the right to add a block to the chain. With the rest of the paper, we get to more low-level details of the Bitcoin implementation. These features are more advanced and go beyond the core of what we need to build an essential blockchain in cryptocurrency. So, for example, features on Section 7 detail an optimization to reclaim disk space through a more performant storing algorithm, so that way the Bitcoin blockchain doesn't take up too much space. There's also a simplified payment verification system in Section 8. And we'll have a payment verification system too, by authenticating the signatures of each individual who performs a transaction in our own cryptocurrency. In Section 9, Nakamoto provides more details on the structure of a transaction. He or she says that it's more efficient to have one transaction with multiple possible inputs, which are the sources of the transaction, and then multiple outputs, which are the destinations of the transaction, which is a feature that we'll support as well. Then Section 10 brings us some information on privacy. Although all transactions must be announced publicly in the blockchain, Bitcoin does support a form of privacy by giving users keys that they share publicly but aren't obligated to attach their name to. And finally, there's a section on calculations, which prove the mathematical efficiency of Bitcoin and the low probability and impracticality of an attacker taking over the entire Bitcoin network. This Bitcoin paper back in 2008 marked the beginning to the blockchain revolution that has taken over the technological world in the past decade. Throughout this course, we'll build a blockchain and cryptocurrency that incorporates these main concepts from that paper. We'll create the blockchain with mining and a proof of work. We'll have a Bitcoin network, signatures, transactions with multiple outputs, and a public key for addresses in our system. So be sure to look out for those features, because once we incorporate them all, we'll have a sibling cryptocurrency to Bitcoin with many of its same characteristics.